Good morning. Today I'll be discussing the properties of the gravitational force, including its attraction between different objects, its mass dependency, and charge independence. Please join me as I explain these fascinating concepts and their implications for our world. Universe is filled with marvelous natural occurrences and forces that work together and affect the other. These four core forces of nature, which are gravity, electromagnetism, strong nuclear force and weak nuclear force, are the ones responsible for producing higher forms of energy and determining the way matter interacts. From the manner in which galaxies are connected to the physical and chemical properties existing in the universe, these forces are effective in all forms of the physical world. Humankind has endeavored to comprehend the prime powers that form our universe. Of the four essential powers of nature, gravitational, strong nuclear, weak nuclear, and electromagnetic, the most conspicuous is the electromagnetic force. This power permits us to perceive light, control our electrical gadgets, and convey through remote innovation. The solid and powerless nuclear forces are answerable for the fastening of molecules in atoms, and the attractive force manages the development of heavenly bodies. Together, these four powers are liable for all the marvels we watch in nature. Gravity is one of the fundamental forces of nature, the force that pulls objects towards each other. Likewise, the strong force binds particles inside an atom together. Electromotive force, while it moves electricity through a wire, is not one of the fundamental forces of nature. Universe is made up of galaxies, consisting of stars and planets held together by gravity. The other three forces, strong, electromagnetic and weak, are also a big part in the creation and sustainability of galaxies. The strong force binds atoms together in their nucleus, while the weak and electromagnetic forces are responsible for interactions between particles. Obtaining knowledge of how these forces affect our universe is an essential element to understanding its behavior. Gravitational force is an undeniable reality that affects everyone. It is the power that binds planets in their orbits, holds us to the ground, and is responsible for multiple natural events. Gaining knowledge of this force can help us to gain a more comprehensive understanding of the natural world. Gravitational force is a powerful force of attraction that exists between any two objects with mass. It is responsible for the binding of the solar system and keeping the planets in their orbits. Despite its exact nature being subject to debate, the effect it has on the universe is undeniable. This fundamental force of nature shapes our universe and provides insight into how objects interact and move when understood. By exploring the physical world, gravitational force becomes an essential part of understanding the universe. Gravity is the dominant force in nature that produces an attraction between two objects based on their mass. This force can be seen in a variety of ways, ranging from the motion of the moon around the Earth, to the movement of planets around the Sun, to the formation and development of stars, galaxies, and galactic clusters. Every occurrence is dictated by the law of gravitation, which we know to be uniform across the entire universe. Gravitational force is a universal force of attraction between masses in the universe. This force is not influenced by the medium between the two bodies and usually has a negligible effect on lightweight objects. This force is established through an action and reaction pair, which means that the forces applied are always of equal magnitude but in opposite directions. The characteristics of this force can be determined by taking into account the distance between the two bodies, the masses of the bodies and their respective acceleration. Gravitational force is a fundamental part of our universe, impacting large objects such as stars and planets. Despite being the weakest of the forces, it has the longest range effect and can be felt throughout the cosmos. Additionally, it is a conservative force, meaning the energy in a system is preserved over time. Gravitational force is transmitted through gravitons, and its strength is determined solely by the mass of the objects and not their charge or other characteristics. Gravitational force is a formidable force of attraction between two masses that extends beyond any limit. It affects everything in the cosmos, and its result can be witnessed on Earth as tides and its impact on the planets in the solar system in the form of orbits around the Sun. Exploring gravitational force further has enabled us to discover some of the mysteries of the universe. Gravity is a remarkable feature of the physical environment. Its potency varies depending on the mass of the object and has a longer reach than any other force. Although the power of gravity is weaker than the other forces, its effects can be felt everywhere in the solar system. Electromagnetic force is one of four fundamental forces of nature that are behind many of the physical phenomena encountered in nature. This force is accountable for electricity, magnetism, radio communications, and even light. It is used to power our homes and workplaces. Radio waves enable us to communicate distant from each other, and its manifestation also allows us to see due to the properties of light. It is powerful and can be adapted to many different uses. Electromagnetic force is one of the fundamental laws of nature and has a fundamental role in how particles interact with each other. This force is responsible for keeping electrons close to the nucleus of an atom, forming molecules and building the physical world we are familiar with. Without this force, life would not be the same. The electromagnetic force is one of the four fundamental forces of nature, its power being 10 to the 36 times stronger than gravity. It consists of attractive and repulsive components, as a result of the interaction between two charged particles. Despite its complexity, technological advancements have allowed us to utilize this force to generate various applications that have become an integral part of our daily lives. Electromagnetic force influences all aspects of our physical world. An applicable quantum field theory states that the force between two charges is transmitted through the exchange of photons. As a result, electrical and magnetic fields, light, sound, and heat are all affected by the electromagnetic force. Through analyzing this force, we gain an understanding of the essential characteristics of our physical world. Electromagnetic force is an incredibly powerful property that works through electric and magnetic fields, disregarding the masses of the affected objects. Its uses are varied, from motors in industry to medical imaging and beyond. The strong nuclear force is a powerful force that originates from within atoms and binds protons and neutrons together. It is significantly stronger than the electromagnetic force, which is responsible for binding molecules together. The strong nuclear force is the underlying cause of matter taking the forms of solid, liquid, or gas and is regarded as being the strongest force in nature, determining the stability of matter. Nuclear forces play an essential role in the physical world. Both strong and weak nuclear forces have an influence in uniting nucleons to form the nucleus of an atom. The strong nuclear force stands out for being extremely powerful, and is the reason for the steadiness of nuclei and making way for the production of heavier elements. The weak nuclear force, even though it is not as powerful as the strong nuclear force, it still has great significance, since it governs nuclear decay and allows us to exploit the energy of some radioactive components. The strong nuclear force is essential for the foundation of atoms. It is what binds protons and neutrons in the nucleus. This immense power works from a distance of less than a trillionth of a meter, and works to keep matter and energy locked together. The strength of the force shapes the stability of atoms, and is a defining influence in our physical world. Strong nuclear forces are an incredibly powerful force with an incredibly short range, being charge and spin independent with a range of only 10 to 15 meters. It is the strongest of all the fundamental forces and is responsible for the attraction between nucleons, providing stability to the nucleus. This is due to the exchange of mesons, making them vital. The weak nuclear force is one of the four fundamental forces of nature, and is responsible for the decay of certain particles, like neutrinos. It is the weakest among the four and is also responsible for the fusion reactions occurring in stars, allowing them to produce and emit light and heat. The weak nuclear force is the force between the elementary particles released during the radioactive decay of a radioactive substance. This force is responsible for the release of radiation energy when an atom decays. Radiation from this process is made up of elementary particles and can have effects that are both harmful and beneficial. Weak nuclear force is a fundamental force which plays an important role in understanding the physical world. It is a type of attraction which occurs between particles like electrons, neutrons and others, and it is responsible for the nuclear beta decay. It is the weakest among the four fundamental forces, but it is still more powerful than gravitational force. Its range is extremely small, measuring only 10 to 2 fm or 10 to 17 meters, which is incredibly minuscule. It is the weak bosons that are responsible for relaying this force. On a scale of strength and range, the strong nuclear force, FSN, is the strongest, followed by the electromagnetic force, Fe, the weak nuclear force, FWN, and the weakest, gravity, FG. Gaining an understanding of the disparities between these forces can provide greater insight into the workings of the physical world. The weak nuclear force is the weakest of the four fundamental forces in nature. It has an extremely short range of action and is responsible for phenomena such as radioactive decay and processes involved in fusion. Specifically, it is responsible for beta decay, a process where an electron or positron is released when a neutrino absorbs energy. Furthermore, the weak nuclear force is also responsible for the conversion of protons and neutrons in a process called the beta decay. As our scientific knowledge increases, it is becoming evident that the physical world is an intricate system of forces. From the microscopic level to the far reaches of the universe, a number of influences, both understood and unknown, shape and form the reality we know. With further technological and scientific advances, we will be able to closer unlock the secrets as to how these forces interact and affect one another. As we work to expand our knowledge, we may eventually come to a clearer comprehension of the physical world. Physicists are attempting to join the electromagnetic force with the weak nuclear force and strong nuclear forces, possibly leading to a grand unified theory of the four forces. This unified comprehension of the universe would provide an in-depth insight into the physical laws and could possibly develop the means for a more substantial model of the natural world. Einstein may not have managed to unify gravity and electromagnetism, but scientists have made considerable progress since then. In the last few decades, the electromagnetic and weak nuclear forces have been combined into a single, electro-weak force. There have been further attempts to incorporate the gravitational force in with the other fundamental forces, however the results of these endeavors have yet to be conclusive. James Clerk Maxwell, a Scottish scientist in the late 19th century, was able to unify electromagnetism and optics, providing the ability to analyze electromagnetic waves according to their frequencies and wavelengths. His culminating work resulted in the four Maxwell equations, which formed the basis for the current comprehension of the actions of electromagnetic fields. Isaac Newton, the great physicist, is known for unifying the terrestrial and celestial domains under a single law of gravity. His advancement in science, which has remained relevant even to this day, was achieved through mathematics and calculus. Through his research on the movement of planets and their orbits as well as the forces that maintain such motion, Newton was able to develop the law of universal gravitation. Therefore, when contemplating who unified the terrestrial and celestial domains under a single law of gravitation, the answer is unequivocally Newton. Laws of nature are essential for understanding the behavior of physical world. They form the basis for scientific theories and play a major role in technology, engineering and mathematics, which are essential elements of our modern society. Ranging from the simplest, for example gravity, to the most complicated such as quantum mechanics, the laws of nature provide the important understanding we need in order to navigate our physical world. Physicists explore our universe to uncover its secrets, ranging from measuring tiny particles to understanding distant stars. They use scientific processes to seek the truth and uncover evidence that can improve our comprehension of the environment. By making these discoveries, they gain insight to our universe that may otherwise go unnoticed. Physicists endeavor to uncover the laws that govern the physical world. Various components may manifest variations over a period of time during a physical event, yet an intriguing and significant phenomenon is that certain physical quantities remain unchanged despite other variables being in a state of flux. Physical entities and their inherent patterns provide a base for understanding the natural world. Mass, energy, linear momentum, and charge, among other physical entities, remain constant throughout a physical process. Conservation of these physical entities is not only important but is also related to the symmetries of space, time, and other symmetries that govern the forces of the universe. Objects falling freely under the influence of gravity can be extremely fascinating. As the object falls, its kinetic energy and potential energy are continuously changing. However, the total energy of the object remains constant, as its initial potential energy is converted into kinetic energy just before it reaches the ground. This concept is truly incredible. The law of conservation of energy is an important cornerstone in comprehending physics across all fields. It expresses that energy cannot be generated or eradicated, but can be changed from one form to another. Einstein's significant equation, E equals mc2, proves that mass can be changed to energy, which is the cause of nuclear processes like nuclear energy generation and nuclear explosions. Grasping and utilizing the energy of the law of conservation of energy can be very influential. Energy is a fundamental element of our physical world, which can be measured with a scalar quantity. But this is just the start. Along with scalar quantities, other conserved quantities like linear momentum and angular momentum are crucial for completing the puzzle. These conservation laws of nature, based on Newton's laws of motion, have a huge influence outside of mechanics, thus enabling us to acquire a better understanding of the physical world surrounding us. Conservation laws are known to have a deep impact on the physical phenomena that occur in nature. These laws are found to be associated with the symmetries that exist in nature. One remarkable example showing this is the unchanging nature of the laws of nature over time. Experiments conducted previously can be repeated again after a year's time and still yield the same results. The symmetry of nature regarding time is then linked to the conservation of energy law. There is a symmetry in the natural laws governing the physical universe, which manifests itself in the form of the conservation of linear momentum. This fundamental property means that the same laws apply regardless of one's location in the universe, illustrated by the fact that the acceleration due to gravity on the Moon is 1/6 that of the Earth, yet the universal law of gravitation remains constant. The symmetry of the physical world allows us to gain a better comprehension of the behavior of all objects within it. Conserved quantities are physical quantities that remain unchanged in a process. These can be either scalar or vector quantities, and this multiple-choice question provides options A, B, C and D to identify which of these types of quantities stay the same throughout a process. Symmetries of space and time have considerable relevance in contemporary theories of the basic forces of nature. A frame of reference, which is essential to comprehend our physical reality, is part of this concept. Einstein recognized the intricate intricacies of the physical world yet still believed that it was guided by fundamental principles. He famously put forward the notion that our physical world, despite its size and complexity, is still understandable. He realized that although we may not be able to figure out every last detail of our physical reality, these same laws allow us to gain a deeper insight into its marvels. It is a fact that the world is round was once considered a heresy by many, however Galileo Galilei was determined to prove it as a dogma. This statement can also be applied to many other theories in science, and the path from heresy to dogma is never an easy one. It takes a great amount of reason, faith and confidence to disprove an existing belief. Science can be viewed as a way of exploring and understanding the physical world. It involves analyzing data, forming hypotheses, and testing to create theories and laws that explain natural occurrences. Just like politics, science is used to find solutions to tricky issues. Solutions that may not be apparent but can be realized if given the right resources and assistance. Consequently, politics is commonly referred to as the art of the possible, and science can be referred to as the art of the soluble. Science and technology advancement in India has been hindered by many factors. Among them, the bureaucratic management of science education in India makes it hard for collaboration between researchers and industry. This means India needs to look to foreign imports for the latest technologies since industry is seen as the actual consumer of new research and technology. Additionally, the brain drain of highly skilled scientists and technologists has worsened the situation, significantly reducing India's potential for growth in science and technology. Advancements of the Industrial Revolution have had a lasting effect on our lives, work, and environment. Steam engines enhanced transportation, allowing businesses to transport goods and services at a faster rate. Blast furnaces replaced the traditional methods of iron smelting, making steel production stronger and more effective. The invention of the cotton gin drastically reduced the amount of time needed to separate the seeds from the cotton, while power looms completely altered the textile production industry. Technology has become increasingly important in our lives, and this transformation persists to this day. As we look to the future, we can see that our current world is in the midst of a second industrial revolution. This shift is leading to drastic changes and enhancements in our society, with advancements in computers, biotechnology, and superconducting materials at room temperature only being some of the catalysts behind this transformation. These innovations will bring about new opportunities that will make the future all the more promising. Pam Dirac's belief that beauty in physics equations is more crucial than the harmony between experiments is highly significant. These equations usually have intricate maths and their beauty resides in their simplicity and finesse. Though this view should be admired, experiments must always remain amongst the priorities. It is essential to keep in mind that, even the most beautiful equations can turn into something of no use if they do not correctly forecast the results of experiments.